So I currently work for Shutterstock in New York City, and we are hiring. So we're also hiring remote. So if you're interested, several of us are here. You can come and talk to me, and I can tell you about how great it is. I'm on Perl IRC as Auggy, and on Freenode as Pork, and I'm also on Twitter. So those are all great ways for you to get in touch with me, and also email. So what we will cover. So this talk isn't going to be an in-depth asynchronous programming. It's not going to tell you about the inner workings of AnyEvent and some of the things there. Really, it's going to be enough for you to do asynchronous HTTP requests and to be able to interface with AnyEvent RabbitMQ and to understand the language that AnyEvent uses, and hopefully to be able to apply that to other asynchronous libraries, whether in Perl or even in Node.js. The other thing that we'll cover is the WorkerQ pattern using RabbitMQ. And again, this will be a very high level thing. I have sample code, which I'll have the link up here. It's not public yet because I've been working on slides and I want to do some code cleanup, but it does run. It'll give you some examples of these things applied in a little application, in a Mojo Lite web app that you can download and run on your computer. So you can play with these things a little bit more. And a bonus side effect of this talk, how to identify if this technology is the right solution for your problem. And so I'm going to get on a soapbox for a moment, because I find in the world of, async and WorkerQ and, like scalability, people like to throw buzzwords around. It's really, really, really important, even when you're evaluating these technologies, that you have a clear idea of what the problem you're trying to solve is, and to understand if these solutions are actually going to solve that problem for you, rather than trying to find a problem or make your problem fit into a cool solution. And I just see this a lot of places I've worked, a lot of people I've worked with. You get it's like, ooh, shiny. I want to use this thing, but we don't really have a use case for it, so I'll just make this thing fit into the use case, and then you end up overcomplicating things. So our sample application is a very simple report. We'll call it the TPS report. What's happening, let's say we have a small company of about 100 people, and once a month everybody wants to get the sales data, and they go to hit the report all at the same time, and we'll say 25% of the users are not able to download the report. They're just getting timeouts. So then they're starting to hit the website more, and this is just an internal website with no external users. And then when they're doing that, then we see website latency reported for all users. So this is like a high-level problem description. The next thing that you want to do after you have a sense of your high-level problem is to identify the cause and clarify the problem with numbers. So if you're not collecting metrics on your website performance, then you definitely want to start, and that's how you can quantify your problems. So some ways that you can do that, you can check your logs for error conditions and see if you can get some statistical analysis from that, what percentage of requests end up with certain error states. You can also collect metrics, which is, I think, the easiest thing to do, and I've done this plenty of times, is just put timing calls. So you just do a Perl timestamp, and then after you make a request, you just take the difference between that timestamp and the current time, and that just tells you, how much time elapsed between those two numbers. You can log that. You can push it to statsd. You can use something like Logly or a log aggregator. There's a lot of cool things you can do, but what's important is that you start capturing that data. The other thing that you'll want to check is if you're using a database, check the long-running query log. Postgres has this, MySQL has this. See what queries are taking the most time. Sometimes rather than looking at a complex architecture like a WorkerQ pattern, just cleaning up your SQL and doing some explain and analysis on your SQL can often fix whatever latency problems that you're having, or will allow you to diagnose so that you can fix whatever latency problems that you're having. Finally, reproduce it in a staging environment if you can mimic the load. That way you can guarantee that this is absolutely the cause of the problem, and so you can really pitch for needing to move to potentially a more complex architecture with more administrative overhead. So examples, the TPS report database query is taking 2 minutes to run. That's ridiculous. That's just, too long. Requests to HTTP services for, data from certain APIs that we need for our report are averaging 1 second. So these are things that are more quantified problem statements that you can definitely solve, and you know you've successfully solved them because you have metrics now with your solution that show that you've gotten the time down. So this is just kind of a preface. This is something that you should always think about before using RabbitMQ, before moving to an asynchronous solution, because there is overhead, and so you want to make sure that these solutions are going to solve your problem. So, you know, once you've proposed your solution, or you propose your solution based on data and facts. So in this case, our solution is that we want to move to an asynchronous model so that we can get our HTTP request time down, and we want to move to a WorkerQ system because timeouts are a poor user experience. And having the reports be in a WorkerQ will prevent those users from having that timeout. They'll just have to wait until their report is done later, but they won't have, you know, this terrible timeout experience. Okay, so our current architecture, we have a Mojolicious Lite app that generates, we'll call it the TPS report. So this makes calls to 2 external services to collect data, and then this will make a complex call to the database. Okay, pretty simple, and our proposed architecture is that we're going to instead move to a WorkerQ system, and so like I said, this involves some systems overhead. You know, another option here, instead of moving to a WorkerQ, again, look at ways that you can improve your database performance. For instance, maybe consider having a less normalized table structure. So if you're making a lot of joins, you might consider flattening that out a little bit. That'll improve some of your query times. Again, think about other options before moving to something like a WorkerQ system, because it does have overhead. It is another piece of software that you now have to maintain. You know, so anyways, there's a lot of different things you can do. But what we're going to do, just so you can see it, is move report processing to a queue and make all HTTP requests at the same time. Now, this is the repo. Like I said, right now it's private because I want to do some code cleanup before I release it to the public so that you don't have all my garbage dumper statements all over the place while I was trying to debug things last night. And I'll get into what I was trying to debug. It's actually pretty cool and very useful. So anyways, but this should be up in a few days and or available for consumption. And it'll have 3 different directories in it. I have pretty good documentation on how to set it up. So you can run the different versions of the application, and you can see the difference in the performance, and you can see the difference in the architecture and the architectural decisions that had to be made to go from one to the other. Okay, so first improvement. We're going to kick off the HTTP requests at the same time. So currently, you're probably all familiar with LWP. This is how you make LWP requests. You set up a user agent, you make your request, you get your URL, and you get your content. This is great, like if you're just calling one. But let's say that we have a database query, and let's say that we need to make 2 calls for our database, and then each one takes, you know, 3 milliseconds to return, because this is a, you know, not the fastest API, but not the slowest. And you know, and each report now is going to return, say, 100 rows of data. So for each 100 rows of data, we have to make 2 calls to an external HTTP service. Because this is happening one at a time, and LWP is what we would call blocking. So it literally, it does one, it waits for the response, and then it does the next one on the list. It waits for the response. Once it gets the response, then it can progress through the loop. So you have literally, like, if we've got 10 URLs and each one takes 3 milliseconds, this will be 30 milliseconds, and you can see how this is just going to increase in the amount of time that it takes to process all of these. It holds up processing. When any one of them, if say it's timing out or say it's just taking a really long time, it's going to back up processing all of the other ones. So let's try using AnyEvent HTTP to get some performance improvements on this. So I'm just showing you the code of what this looks like. We're going to walk through this in a moment, but I want to explain the principle of why we would want to move to an asynchronous solution. What happens is each request is going to happen at the same time. So if a request takes 3 milliseconds, if each request takes 3 milliseconds, the total time for all of our URL requests, if we're doing 300, should be 3 milliseconds, because they all happen simultaneously, give or take, you know, other factors, but in an ideal world. So what happens if one request takes 1 second, then our result will all come in 1 second, because it doesn't return until all of the requests are complete. But since they're all happening at the same time, we don't have that back-to-back you know, where it's, I can't think of the word, but where it's building on top of itself like a snowball. So it only takes as long as the longest request. So this is an advantage. So what does asynchronous mean? Well, we all know the dictionary definition, you know, things happening at the same time. I like to think of asynchronous code as event-driven. It's also referred to this. If you've done any UI programming, there's the notion of listeners. You know, for instance, you have a button. The button registers with some kind of an event, and this event loop just loops and loops and loops, and it just kind of listens for when somebody clicks the button. And so with asynchronous programming, we're applying this to the back end. And now we're saying that we have an event loop. We have an event that we want to listen to, and once this event happens, we want the result from that event, is pretty much in a nutshell. So basically, code is pushed to an event queue that'll fire after all the other code executes. The event loop itself is a queue of callback functions. They're basically just functions that you're passing in when you call your asynchronous, when you're calling for your specific asynchronous activity. When an async function executes, the callback function is then pushed into the event queue. So things don't happen. This is why I called this talk Perl out of order, because things don't happen in the order that you may expect them. They happen when they can happen. And so instead of saying, I want X to happen and then Y to happen and Z to happen, your relationship with the event loop is pretty much like, hey, when you can, I would like this to happen, and then I would like the result once that thing has happened. So the result will be returned in the background, and then the rest of your application proceeds ahead using a placeholder for the result. So instead of, when you initialize a variable, for instance, it's sort of a promise. Actually, it's not sort of, it is a promise. Like it's a placeholder for a value in the future. And so then you can do other things that are not dependent on that particular value. And then at the point where you absolutely need to get the value back from your HTTP request in this instance, then it becomes blocking, and you're like, okay, now everything stop until this stuff is finished, in a nutshell. So basic formula for async: you have an event loop, you have some kind of a listener that says I'm interested in a certain event, and then you have callbacks that trigger when that event happens. So AnyEvent is an abstraction layer on top of event loops. I'm going to go through specifically AnyEvent because it uses some function names and has some terminology that's a little bit unique. And for me, it was pretty confusing when I first started using it because it was different from what I had been used to with other things. But when you start understanding the workflow and the language of asynchronous programming, then you get a sense of what this is, and so you can apply it to other things. So the first one that you might have seen is a function called convar. A condition variable is basically a potential value that may or may not be available right away. This is how you interface with your event loop. So you'll call functions on convar in order to register your interest in different things in the event loop, and in order to register that you want the result back. This does not actually have a value until it's ready. So if you were to try to see what the value of it was, you would see it's like an AnyEvent convar instance, but you wouldn't actually see that it has anything in it until you call the, until you've said that, okay, this is the point where I want it to be ready. The next method that we care about, and again, we'll do a code walkthrough, so you see how all these things go together. But so send indicates that one event is complete by setting the convar as ready. In the case of multiple requests, you can bind a callback to send, which is what I'll show an example of. So that way, when it's ready, you can store values retrieved, and that way you can have the convar go multiple times. So you're not just like going once and then returning, but you can say, you know, anytime this is ready, I want, you know, I want this value. So that's pretty useful. And then finally, receive. This is the point where think of this as the blocking point, and this is important because this has to do with the issue that I was having last night when I was debugging some of my sample code. But receive is blocking. Like when you call receive, you're basically saying, I need the value now. I need you to fulfill the promise, you know, that you made earlier, that you're going to return me a value. So at this point, all of the requests need to complete, and I need this data in order to proceed in my application. So there's another cool thing. There's some syntactic sugar that you can use in AnyEvent called begin and end. Begin and end are a way to, excuse me, if you have multiple requests that you want to run, you basically set that, look, I have a bunch of things that I want to run, and I only want you to be ready when all of them have run. So in any event, it basically increments, it creates an event loop counter, and anytime you make a begin statement, it increments that counter, and anytime you make an end, it decrements that counter. So it'll only be ready once that counter is 0. And you can nest these, you can have multiple layers of them. It's basically, for instance, in our case, we're making multiple HTTP requests. We don't want our convar to return until it's until every single one is complete. And so the way any event tracks that is with begin and end. Now, optionally, you could set up some kind of an array where you create a convar each time it loops through the array, and that would give you the same thing. It's just a little prettier and a little cleaner if you use begin and end. And again, all of this, if you look at the AnyEvent, the main AnyEvent documentation, there's an outline, and the documentation itself can be a little confusing. It can be a little misleading, but hopefully with the explanations I've given you, and after the code walkthrough, it'll make a little more sense when you actually try to apply this and when you actually try to use it. So, all that being said, hopefully it didn't go in one ear and out the other. We'll do a walkthrough so you can actually see what all of this looks like. So the first thing you want to do when writing any event code, and again, I've got sample code on GitHub, and you can look through and play with this. And this is pretty similar to sample code that's in the AnyEvent docs. But first thing you want to do is initialize your conditional variable. And remember at this point, this thing doesn't actually have a value. You've got to call some other things on it. But here we're just saying, okay, I want this, I'm going to want something from it. You're setting up the promise, you're creating the placeholder. The second thing that I like to do is I like to declare my receive function or the receive call, the endpoint. Like, what do I want to return at the ready state? With asynchronous programming, it's a little weird because you start kind of having to think backwards about what you want to have happen. So normally in programming you think, okay, well I'm going to start with the first thing, and then I want to do this second thing, and then I want to do this third thing. With asynchronous programming, you want to think in terms of end results. So what's my expected end point, and then work backwards from there. So in this case, we want that receive value, so we're putting that here on the bottom. So this is the point. And actually, this is really interesting. This sample code that I'm showing you, the idea is here, I decided I had a little library, and so I decided to put my HTTP requests into a function within that library, so it's actually obscured from the person calling it. This is really bad. and I'll explain later why that's really bad. But I thought I would go ahead and leave it, just because the code is going to be the same more or less no matter where you use it, but also to really make the point of why it's really bad, and we'll show later. But in general, this CV receive, you want that to be outside of any logic. If you're defining any kind of a subroutine or any kind of a method within a library, you generally want the person calling it, calling your library, to set up their own CV and to have their own control over the event loop. But again, like I said, we'll get into this. This is just let's walk through this and get an idea of how to essentially do HTTP requests asynchronously. Okay, so remember earlier I talked a bit about the begin block. So what we're saying here is that we want to define when we want to call the send event so that we can capture our result. Because what we want, our result is going to be a hash ref of our URLs. And so we want to capture that. And then it's all, yeah, we want to get a hash ref. Sorry, I'm looking at my code. What was I writing? But we want to get a hash ref of our URLs of the data that we've gotten, from whatever our external APIs were. So we need that data. We need to return it. The way to return it is to bind it to your, or to ask for it with the callback, or with the callback bound through that sub. Sorry, with send. So when registering callbacks with AnyEvent, you can pretty much always count on the convar being passed as an argument. So the reason that we're doing the shift, you guys know Perl, so you know what's happening there. We're basically grabbing the first argument that's going to be passed in whenever that callback is called. And we're passing, and then we're calling, and that will be a convar, and then we're calling send on it. And so yeah, so we're pretty much just calling the convar from the arguments passed in, and yeah, calling send on it. Note that we're calling this from within begin. This is important. We're using begin because we have a list of URLs, and we only want the convar to be ready when all of the URL data has been fetched. So basically in English, what we're saying with this line is once all the URLs are fetched, set the convar to ready and return our resulting data structure. Okay, so next thing, we want to go ahead and set up our end. So we've declared our begin. Let's now set our end so that we decrement our event loop to 0, or decrement our event loop counter to 0. And so this also ensures that that send will get called. If our loop has no data in it, in the while condition, we would loop forever without this additional end here. Because we do have an end being called within our callback, but it's really important that you have it at the end there. So this absolutely ensures that the send that we registered within that initial begin gets called. So finally, here's the part where we make the call to HTTP request. This is the AnyEvent HTTP method that's used to retrieve the URLs. When you make this call, it means that you want the request to be made when possible. You're not saying, okay, I expect this at this particular time, whatever. All you're doing is saying to the event loop, like, hey, when you have a chance, I would like you to, to do this, to run this code. What this does is registers an I/O watcher, and it tells the event loop that we're interested in this particular I/O event. So when the request finishes, we want to do the callback. So we have a sub there that says it's going to get back as its arguments content and headers. So then we want to capture the content, save it into our data structure, and then undef the request to show that we're no longer interested in this, and then call our end so that we decrement our event loop counter to 0. So what happens is this actual method, HTTP request, doesn't actually do anything in terms of processing. It'll return right away, but it tells the loop to call that subroutine whenever possible. So basically to do the HTTP request, and then we want that data. So when that chunk of code runs, it's important to know that the event loop is not actually in control, because that subroutine is what's actually got control. So the event loop says, okay, I got the request. This is the event that we were interested in. I'm going to pass control over to run this chunk of code, and then return the result. So like I said, this is a little confusing, and so that's why I have the sample code. I'll have that up in a couple days for you to play with, so you can see what's happening when things are happening. And finally, yeah, we undef the request because we want to unregister our interest in this particular event. And the inner, begin, and end define what the individual requests that we want to track in each loop are. So for each begin, like I said, the loop will increment a counter. For each end, it decrements, and once the counter is at 0, then we're telling AnyEvent to set the convar to ready. So that means that our promise can be fulfilled for the data that we want. So again, I know some of this stuff, it may sound, and I don't have really good pictures and I'm just showing code, but I just want to say you've got to play with it. It's really weird, and until you've actually played with it and run it yourself and seen what's happening, it's not an easy thing to wrap your head around. It's just something that, that you've just got to run and break. And wonder why it's running forever and you're not getting your result. So when you make a mistake. So asynchronous programming, when should you use it? You should use it when you don't care about the order that things happen, and you have to do a whole bunch of things at the same time. One thing to note about asynchronous programming before you consider going that way is that it can be hard to read and it's really hard to maintain. In this example, we only had I think one callback in there, but I'll show you later on when we start interacting with RabbitMQ, we're going to have 3, 4, 5, nested callbacks in our code that we're having to jump through and deal with. And that can be a real pain to maintain beginning. There is a learning curve. And so there are some really great modules out there. Promises is a really good one, and I think there's some features that can make that readable and make it easier to use. You can also just do simple things like named callbacks. There's a lot of different techniques out there for managing the so-called callback hell. But just be aware that there is a bit of overhead. So always use metrics. Again, going back to my initial soapbox point, use metrics to determine if this really buys you anything. So set it up in a staging environment, run your tests, and then compare the numbers. And if it buys you something, if it's a really big gain, then it may be worth taking it on as something to do to improve things. Okay. So, and I'll take questions at the end. So I know this is, like I said, I know this stuff is crazy. The second improvement that we want to make, and part of why I introduced some of the AnyEvent stuff is because we are using AnyEvent RabbitMQ to talk to RabbitMQ. So that way you can kind of understand like what some of those variables mean as we're looking at that connection logic. So the second improvement is we'll go ahead and create a work queue. This can also be referred to as the publisher subscriber model. The idea is that you push the work off. So if you have a web application that needs to do some work, you push that work off to a worker script. And so you say you create essentially a ticket in some kind of a message, or a ticket, like a message, something. You think of like people working, if you've ever worked IT or any kind of customer support, you get tickets. Customer calls in, makes a complaint, you get a ticket, and then somebody eventually picks it up, does the work, and marks the ticket as done. And so essentially that's what we're implementing. You have your web application pushing something off to a queue. You have a worker script that you might have running, say, via a cron job, and that worker script then checks the queue for any jobs that need to be done, does the work, and posts the results somewhere, which then your web application can consume. That's a very specific example, but worker queues can be used for a variety of problems. So what kinds of things are they good for? So in this example, there are a few different options you have if you want to use a WorkerQ pattern. I happen to have used RabbitMQ, and I like it all right. There's also Redis requeue, where you can use Redis. There's a Perl library called Redis requeue that lets you treat Redis as a queue. You can also just use a table in a database. I mean, really all you want is something that's going to store messages. I like RabbitMQ because it's basically made for that. It's made for message passing, and there's no order guaranteed to the messages, so it's not necessarily a first in, first out. And I think that it does a pretty good job of message management. So like if you have, like say you have a cron job and you have a worker that's stuck processing some job and it's been doing it for a long time, and then the next one kicks off, it's not going to pick up the same message. RabbitMQ is pretty good at managing who's gotten what. So that's something, and you can also configure it to do some pretty fancy forwarding of messages throughout queues. So I'm not going to go into all of that, but I would recommend that you check out the RabbitMQ docs if you think this sounds like something that could work for a problem that you might be having. Okay, so here's a big question. What does asynchronous programming have to do with RabbitMQ? What are these things? Why are these even in the same talk? Well, RabbitMQ has a special way of requiring connections. Sockets traditionally are blocking in that the actual connection attempt will block until the connection is available. Any of you that have done socket I/O and had timeouts, is everything freezes, everything locks until this thing returns. So RabbitMQ is a little bit different. In Perl, we typically use AnyEvent RabbitMQ to talk to RabbitMQ, but I know that there are a few other options out there. Just this is the one that I've used and the one I've seen most often. But anytime like you need to wait, say, for HTTP requests, you need to respond to error messages, you want to be able to manage this in a timely manner, and you don't want to be stuck waiting on a socket connection. In addition to that, RabbitMQ does expect a little bit more from its listeners. So here's the caveat. If you're using a web application that's blocking, a typical web application only gets control whenever it receives a request. Whenever somebody says, okay, I want /foo, then the web application says, oh, okay, let me give you that. RabbitMQ, on the other hand, when it makes a connection, it has listeners and publishers registered with it, and it'll send a little ping called a heartbeat, and it needs to make sure there's something to respond to it on the other side. Otherwise, it'll stop sending messages. So basically, you have to have something that can listen to the heartbeats and respond. You need an event loop, basically. If you can't do that easily in a blocking framework because you are only in control when you get a request. So what will happen is RabbitMQ will hang up on you. So unless you want to hang up and reconnect every single time you send a message, then you could potentially run into some problems there. So Mojolicious, fortunately, has a Mojo I/O loop that will handle multiple reactor backends. Dancer, I was just speaking with Yannick, has a plugin. Is that right? A plugin? Mm-hmm. Yeah, has a plugin that'll Dancer 1 that'll help with some asynchronous stuff, and I'm not sure about Dancer 2. So other things. That's a big question that you want to ask with your web framework. How does it handle I/O loops? Does it have an asynchronous I/O loop? How does it work with these kinds of things? So that's an important question to know before you decide to use something like RabbitMQ. So basically, the publisher needs to create a connection with the RabbitMQ server. When the connection is established, an exchange is created, and then the exchange handles all the incoming updates and redistributes them to the available queues. So when an exchange is created, that means messages can be sent, this is the AMQP protocol that RabbitMQ uses, and this is just one particular way of implementing this. So essentially, if you don't remember anything else, just remember, if you don't have a response to the heartbeat, you're not going to have a RabbitMQ connection, and you're going to have connectivity issues in your application. So this is why we're setting up an asynchronous connection to RabbitMQ. So step 1, we want to replace the original work section with pushing a message to RabbitMQ. So again, there's a lot of stuff here. You need to think about how you want to record. Do you want to keep a record of the queue data? Do you need to recreate the queue? Anything you push to RabbitMQ, like how important are these messages, or is it okay if they get lost? With RabbitMQ, you're typically not going to get any persistence. There are some options too, but just think of it as like, if it's really important, you probably want to have some kind of a record somewhere, or maybe you want to use something a little different for your queuing. But if all you're doing is like things that can be forgotten, like in the case of these report generation requests, maybe in the sample application, the user has a list of their report requests. If something happens and something gets lost, the report will never update, and so then, so then you might want a mechanism for that. In this case, they would just call you and say, hey, why didn't my report ever run? Oh, just resubmit it, and then we'll figure it out. So our first thing that we're going to do, this code probably looks a little familiar because we have our convar, and then we set up our RabbitMQ connection. These are basically the default values when you install RabbitMQ initially, and that's what's being used in the sample app. So here we're registering that so we're setting up our connection. And then here's where, so open channel is pretty similar to our HTTP request. You know, we're making our function call, and we're saying, and now in this you'll see something a little different. If you've done any Node, this looks a little bit like that, where you say on success, this is what I want. In the sample code and on the module AnyEvent RabbitMQ, there's also conditions for on failure, so that you can handle different events that might happen depending on what happens with your connection. But here we're going to declare a queue. We're saying I want the reports queue, and then we publish our body. You know, we set up our header because we want to use JSON. We set it to the body, and then our routing key there is actually the name of the queue. So we set that up, we publish it, and then we call our send event. So when we call that send event, remember that says, okay, this is our ready state. So once this has been posted to the channel, or once this has been published to the queue, we're done. And so then I want the convar to return. We don't actually want anything back from the convar. So in this case, it's, you know, it's pretty straightforward. But that's how to read that code. If anything, just think of, okay, there's a convar, there's some kind of a function call there, this open channel that's registering our interest in that event, and send is saying now we're done. So step 2, we need to move the work to a worker script. So a few terms to look for here, and again, you can look at the AnyEvent RabbitMQ stuff to get more information, but these are some of the key things here. Again, our method, instead of, so we have our open channel, and we're using a callback bound to an on success condition as before. And so in this case, we want to consume the message. And so that's in our in AnyEvent RabbitMQ, that's the word for give me the message. This is an example of how you would get the content from the message, or the message is passed in to the callback as the first argument there. And so then that's how you get that data. So you get the payload from the message. The channel ACK, that's just telling RabbitMQ that we received the message, so don't let anybody else process this one ever, because we're done. We've done it. Let's see. Oh, so this was the code that I originally wrote. So remember that here I'm calling this report builder, build report thing. Now in build report, we're doing this HTTP, the asynchronous HTTP requests. Okay, that's pretty cool. So we're doing this work with RabbitMQ. We've got an asynchronous thing going on here. We've got an event that we're interested in, and then we've got something else going on further down in the library stack, where we're calling these URLs. These URLs, this is just showing, so sub build report makes a call to this get data from URLs. And then here at the bottom, we've got this receive event. So what happens if we actually run this code in this state? You get this wonderful error that's telling us that within our functionality, we have a recursive block, or because receive blocks. So we have a blocking condition. We're trying to tell our the event loop, like, you know, stop here. I need this right now. And event loops just don't. I mean, it just doesn't work. That whole process just doesn't work that way. So this is why it's really important when you're doing these libraries that you need to move things up to the top level. The way you move things up to the top level is that you use callbacks. Not CV. You only use CV at the highest level. So this was a mistake in the previous library design. There's something else. So you fix that, but then you've got to use callbacks, because here you see how we're passing in, we're getting this HTTP data result, and then we say get data from the URL. So after our request is done, we want that resulting data structure. The problem is that HTTP data isn't going to get back the data structure that we expect. Anything that depends on any sort of return value actually needs to go into a callback. So that's why callbacks, when you start getting into asynchronous programming, you start seeing all these nestings of callbacks, especially as you get more abstracted functionality. So how would we change this? Well, the first thing that we would want to do is in our library, in our subroutine, where we're calling the report builder, we want to change our get data from URLs, because remember, this is where we're doing the work to call to get our stuff from these external APIs. So we want to move all the stuff that we're doing after that call with HTTP data and anything that depends on that into a subroutine. And so we'll do stuff. So we'll do all of our stuff in there instead of instead of relying on that as a return value and then doing it in the more procedural manner. We also want to replace that receive that we had at the bottom in our original function, and we want to make a call to the CB function. So whenever it completes and something is sent to the CV, when our convar is ready, the CB function of the CV basically calls a function as soon as it completes. So as soon as we hit send, this callback function is going to trigger. I know this is, like I said, this is a little bit crazy. So finally, so let me see. Yeah, that's probably, anyways. So essentially, I'll have sample code up that covers this on GitHub. So you can actually see it in action, you can play with it, you can try to break things, and I think that'll be pretty helpful. I hope it'll be pretty helpful. So in a nutshell, I know this was like a lot of information, and I know it was, you know, asynchronous programming, I'm just going to end and say it's not easy, and there's no easy way, I think, to explain it. And so my approach has really just been, let's take some real life examples, let's try, you know, let's just see what happens when you actually try to do things in the wild. And I wanted to actually show, really quick before I take questions, what the sample looks like. Let me see if I can. I normally use Xmonad, and I've been trying out Ubuntu Unity, and I don't know how I feel about it. But here's our sample report. This is a lovely, helpful report name. You know, but here we're getting, you know, we'll say it's a weather API that's getting some weather. We're getting a random image, and then here's the repo that'll be available as soon as I do some code cleanup on it and clean up the commit history, so it's actually useful. But just really quick, it'll have 3 folders here. The original version, which is the one that takes a long time, the blocking one. We have our async version, which is the actually kind of bad library implementation, so you can play around with that and understand why it's bad, but also see some of the benefits of switching some simultaneous HTTP requests. And then our WorkerQ example, and so that you can actually see like what happens when you have to make like nested asynchronous requests, but then also have some sample code that you can use for talking to RabbitMQ. So that's it. And I'm happy to take questions. I may or may not be able to answer them. Yes?
Where do you get your pictures of people with carrots for earrings?
Well, I work for Shutterstock, which is a stock photography company. And so just so you know, with the sample code, there are some images. These are only for use with the sample code. They're not to be redistributed because they are licensed stock photography images. So that's the disclaimer. It'll be up there. But I think they're such cool images. I'm gonna flip back to that. There's all kinds of cool stuff up there. Anyways, yes, right there.
So in your example where you were calling the ACK back to MQ, is that happening after all your HTTP requests have finished or after you've queued them on?
Right, so it actually happens, I believe, after, maybe somebody else can clarify if I'm wrong, but I believe it happens after. So you make all your HTTP requests, and then you've registered that send event outside of the HTTP requests. Wait, the ACK for the RabbitMQ, yes, yeah, it happens after everything else is done.
So does that mean you're at a risk of another worker picking up the same job?
No, not with RabbitMQ. And so with RabbitMQ, it basically, it'll reserve the message. And Redis Requeue does the same thing. When a worker picks up a message, it's because with RabbitMQ, it uses that publisher subscribe model. So when a worker picks up a message, it knows that a worker has picked up a message. So it'll reserve it for a short period of time until later. And I recommend, even in your error conditions, like if something fails with processing the message, I recommend that you go ahead and ACK it, because you don't want to have the same message being picked up a whole bunch and, like, you know, dirtying up your logs. I think it's better to pick up a dirty message or a fault, something that's errored, and then just lose it. Like basically log, I wasn't able to do this, here's the data, and then just dump it from the queue. So that way, you know, when the user, assuming you have some other process that's monitoring, comes to you and is like, hey, what happened to my report? Then you can look at logs and see what happened without it backing up everything else. Yes?
In your condition variable, first time you call begin, you were passing a subroutine to a callback in there.
Yes.
When is that executed? Is that executed when that hits the condition variable hits 0, or?
Yeah, so that's actually executed when the condition variable is ready. So, and it's ready when, like if we're using that begin and end block, whatever that counter is in the event loop, when that hits 0, that's telling it yes.
So if you called that multiple times as you were incrementing, they would all be fired when you've received the same number of ends.
I'm sorry?
So if you put multiple, you're calling begin multiple times.
Yeah.
You pass multiple subroutines to that each time you call, they would all be called.
Yes.
Hit the right number of ends at the end.
Not quite actually. It's just the last callback that you pass into that. That's going to be called.
Okay, so it's the last time when you set begin the last subroutine.
Yeah, it's like when all of them are completed, when the count hits 0, then the last callback that you provided is the one that's going to be called.
Yeah, sorry, I should have been more clear about that in the slide. But yeah, you only register it with the first begin, because that's your ultimate ready state. Like that's where you're like, this is the end. This is really, no, I mean, this is really when we're ready. How am I doing on time? It looks like I have about 4 minutes. Does anybody else have any questions?
So anyway, when you say it's doing the work simultaneously, is it like threading and simultaneously, or how's it simultaneously?
That's a good question. Does anybody who knows the guts of AnyEvent? Like for me, I just know, like, I don't know, it has this event loop and it does things.
Unless you use some extra stuff, you're single threaded and just in an event loop.
So, okay, so it's still a single thread. It's not quite simultaneous.
Yeah.
It just doesn't block waiting for all the responses to come back.
Right.
It schedules them and then.
Yeah, so right, so it's scheduling things, it's sending off the requests, and then it's kind of like if you think of like when you click a mouse button, like you just have a listener running on the button in the UI, right. And so it's just listening specifically for that response for that one particular event. So in this case, it's specifically listening for that IO event to have some data come back.
So this is confusing, right? Because GUI is usually implemented with multi-thread.
Right. Oh yeah.
As an example, it then brings in the imagery of multi-thread, but
right.
It's not multi-thread at all.
Yeah.
Well, but at the point where if you have broken it out into like WorkerQ, then of course you can run as many of those work processes to get proper congruency.
Yeah. All right, well, thank you so much. And again, feel free to email me, or if you think of any questions, or like I said, I'll send something out to the YAPC mailing list when, and post, I guess, in the IRC channel when I've got the code published. But like I said, I know this stuff is confusing. For me, like recently, like learned how to use it and felt I should do a talk about it so that I can explain why. So, and I was hoping, thank you, that there are people in the audience that understand the why a little better than I do. But I was hoping, like as a person that's had to navigate this landscape, that maybe having to explain it to you from that perspective might be a little more helpful. So.
Well, feel free to return tomorrow.
I know, right? Thank you. All right, well, thank you very much, everyone.